So guys, let's begin our discussion over the JEE main pattern exercises for inverse trigonometric functions. The first question says that if 4 sine inverse x plus cos inverse x is pi, then x will be what? Now over here there is a clear connection between sine inverse x and cos inverse x being visible over here. So I will be interested in using the property that sine inverse x plus cos inverse x is pi by 2. So cos inverse x is pi by 2 minus sine inverse x. So this is pi by 2 minus sine inverse x, and this is given to be as pi. Now 4 sine inverse x minus sine inverse x gives you 3 sine inverse x, and pi minus pi by 2 gives you pi by 2, right? So sine inverse x becomes what? Pi by 6, and x becomes sine of pi by 6, which is 1 by 2. So what is the value of x? The value of x therefore comes out to be equal to 1 by 2. Everything is in the principal domain. Fine. Moving to the next question, let's see what we have. We have tan of cot inverse x is equal to what is the question. Okay. So again, if I talk about the very same property, tan inverse and cot inverse connection, it reminds us that tan inverse x plus cot inverse x is pi by 2. So cot inverse x can be connected to tan. How? I can write cot inverse as pi by 2 minus tan inverse, right? Now you know tan of 90 minus theta is cot theta. So this becomes cot of tan inverse x. So using the two very basic properties related to trigonometric and inverse trigonometric functions, I was able to conclude that okay, this particular expression of tan of cot inverse x is actually equal to cot of tan inverse x, and that is what is my answer. Fine. Next question says what? Let's see. If tan inverse of a by x plus tan inverse of a by x is pi by 2, then what is x? This is not a, this is b. Tan inverse of a by x plus tan inverse of b by x is pi by 2, then x is what? Over here very clear cut thing is visible that tan inverse a plus tan inverse b is what? It is equal to tan inverse a plus tan inverse b is tan inverse a plus b. So it's a by x plus b by x, a plus b upon 1 minus ab. Right? Tan inverse of a by x plus tan inverse b by x is tan inverse of a by x plus b by x upon 1 minus a by x into b by x, which is ab by x square. This is given to be as pi by 2. Now realize one very nice fact about the tan function, that this would mean a by x plus b by x upon 1 minus ab by x square is tan pi by 2, which is an undefined or not defined quantity. If this quantity is not defined, that can only happen when the denominator is 0. Only then can this quantity not turn out to be a real number, in which case it is going to become a not defined or undefined quantity. Therefore, if this is an undefined quantity, this means 1 minus ab by x square is 0, or ab by x square is equal to 1, or ab is x square, or x is root ab. So it is the value root ab which x is going to assume if tan inverse a by x plus tan inverse b by x has to come out to be equal to pi by 2. Now the moment you have this over here, you have understood that the very fact that this was not defined led us to the conclusion that this should be 0 and hence x should be root ab. Clear? Next question says that if cos inverse x minus cos inverse y by 2 is alpha, then what is this value equal to? Let's see. Cos inverse x minus cos inverse y, well, what is this equal to? Cos inverse xy, so it is xy by 2 plus under root 1 minus x square into under root 1 minus y square, which over here is y square by 4. This is given to be as alpha. So cos inverse x minus cos inverse y is cos inverse x into y plus under root 1 minus x square into under root 1 minus y square. This is given to be as alpha. So you get xy by 2 plus under root 1 minus x square under root 1 minus y square by 4 equals cos alpha. Fine. Now over here, if you can very easily see, I want to get rid of these square root signs. So what do is, I perform this step. I take xy minus xy by 2 to cos alpha and leave these square root sign expressions alone. I get 1 minus x square here and 1 minus y square by 4 here. Now you square both sides. You get cos square alpha plus xy by 2 whole square minus 2 into xy by 2 into cos alpha. So it is xy cos alpha. Fine. This is equal to square of this into square of this. That means 1 minus x square. This is 1 minus x square into 1 minus y square by 4. So what is this equal to? This is equal to 1 minus y square by 4 minus x square plus x square y square by 4. So you can see this and this gets cancelled out. What are you left with is x square plus y square by 4 minus xy cos alpha is equal to 1 minus cos square alpha, which is sine square alpha. Fine, if you take out the LCM, you get 4x square plus y square minus 4xy cos alpha is 4 sine square alpha. So the question was, what is 4x square minus 4xy cos alpha plus y square? And the answer is that this expression is actually equal to 4 sine square alpha. Clear? That is my very solution. Okay? Moving on to the next question, we have a root of this equation is what? One of the roots you have to tell of this given equation. Let's try to see how do we actually compute the root. Now over here everything is comfortable. Everything is in the algebraic format. The only thing which is of trouble is this portion. So let's try to resolve this portion first. This is tan of 2 tan inverse 1 by 5 minus pi by 4. 2 tan inverse x is tan inverse 2x upon 1 minus x square. Understood? 2 tan inverse x is tan inverse 2x upon 1 minus x square, tan of this minus pi by 4. Fine. So this is tan of, this is 2 by 5 whole upon 24 by 25. So what you get basically is 2 by 5 into 25 by 24, which gives you 5 by 12. Right? And pi by 4 I can write it as tan inverse 1. So now you have tan inverse A minus tan inverse B, which is what? What is tan inverse A minus tan inverse B? It is tan inverse A minus B. So 5 by 12 minus 1 upon 1 plus A into B. So this gives you what? This gives you tan of, tan inverse of, this is minus 7 by 17. Okay? Now over here this comes out to be minus 7 by 17, and therefore what we have obtained is that this complete bracketed term is actually minus 7 by 17. The moment we have resolved this, life is very simple for us now. Why? Let's see. Now I have 17x square plus 17x into minus 7 by 17, which leads me to cancel this, minus 10 equals 0. So you have 17x square minus 7x minus 10 is 0. You can write this as 17x square minus 17x plus 10. X minus 10 equals 0. This gives you 17x, x minus 1 plus 10, x minus 1. So you get x minus 1 and 17x plus 10, which gives you x equals 1 and x equals minus 10 by 17. So one of the roots of this equation, this complete equation is 1, another is minus 10 by 17. Question was one of the roots, and that is equal to 1 in this case. Fine. Next question, let's see what is it. If x belongs to minus 1 by 2 to 1 closed interval, then sine inverse of this expression is what? So over here what we are going to do is basically to manipulate this expression. I need somehow sine inside, so that sine inverse of sine of something can help me to reduce this given expression to the algebraic form, and then we can very easily proceed with that. So over here what I am going to do is x is anything lying between minus 1 by 2 to 1. It is very valid to assume that x is sine theta, right? Because sine theta lies between minus 1 to 1, so obviously minus 1 by 2 comma 1 is contained in minus 1 1 closed interval. I can very easily assume that sine theta is x. Now it is given that x is lying between minus 1 by 2 to 1, that means sine theta is lying between minus 1 by 2 to 1. So theta is basically lying between what? Sine inverse of minus pi by 2 to sine inverse of 1. This is the very range of theta. Now understand this. This is sine inverse. This is root 3 by 2 into x. X is what? Sine theta. Root 3 by 2 can be written as cos pi by 6. Right? Then you have minus. If sine theta is x, we know that in trigonometry we have done cos theta is under root 1 minus x square. Because sine square theta plus cos square theta is 1, that is why. So over here under root 1 minus x square is cos theta, and 1 by 2 is what? Sine pi by 6. So it is sine a cos b minus cos a sine b, which is sine of a minus b. Now I can write sine inverse of sine of theta minus pi by 6 to be equal to theta minus pi by 6 only when this theta minus pi by 6 lies in the principal domain of sine, which is minus pi by 2 closed interval. And that is pretty much true. Why? Because theta is lying between minus pi by 6 to pi by 2. So theta minus pi by 6 lies between minus pi by 6 minus pi by 6, which is minus 2 times pi by 6, which is minus pi by 3, and pi by 2 minus pi by 6, which is 2 pi by 6, which is pi by 3. So because theta minus pi by 6 is also lying within minus pi by 2 closed interval, I can write this as this, and theta is what? Sine theta is x, theta becomes sine inverse x minus pi by 6. So sine inverse x minus pi by 6 is my very correct answer. Clear? That's how you deal with this question. Next question what we have is the value of a for which this expression is 0 has a real solution is what? Let's see. Okay, so over here everything is good. Sine inverse of this and cos inverse of this has been taken. Sine inverse of anything or cos inverse of anything is valid only when that anything is lying between minus 1 and 1 closed interval, right? So is this lying in minus 1 1 closed interval or not? Let's see. For all values of x. So x square minus 2x plus 2 can be written as x square minus 2x plus 1 which is x minus 1 whole square plus 1. This quantity is always non-negative. If this is always greater than equal to 0, then this is greater than equal to 1. That means this quantity for any x you pick up as a real number will be either 1 or strictly greater than 1, not less than 1. So that means only and only when this quantity is equal to 1 is my sine inverse of this quantity and cos inverse of this quantity defined. If it moves beyond 1, my sine inverse of this quantity and cos inverse of the same quantity is not defined, because sine inverse and cos inverse are only defined when the very values which they can act on is lying in -1, 1 closed interval. 1 is the limit, upper limit. You cannot move beyond it, and therefore only when this value is 1 can this complete expression be talked about. So only for x equals 1 we have this valid. So when you put x equals 1, you get a plus sine inverse 1 plus cos inverse 1 is 0. What is the value of a? This is a plus pi by 2 plus 0 is 0. A is minus pi by 2. So basically your answer is a is minus pi by 2. Clear? That's how conceptually also many a times questions are dealt with. So let's look at the next question. We have if 6 sine inverse x square minus 6x plus 12 is 2 pi, then the value of x should be what? Let's see. Now again over here, if you can very nicely understand, sine inverse of this expression is being written. Now sine inverse of anything is only defined when that anything is lying in -1, 1 closed interval, otherwise it is not defined. So this particular thing has to be greater than equal to -1 and less than equal to 1 for it to be able to sine inverse to be acting upon it. Now over here we have x square minus 6x plus 12. Clear? I can write this as x minus 3 whole square plus 3, because it will be what? X square minus 6x plus 9 plus 3. So 9 plus 3 is going to give me 12 again. Now this quantity is always non-negative, right? In a non-negative quantity, when I add a positive quantity, obviously this is also non-negative, but in fact it is greater than or equal to 3. It can minimum be 3, maximum it can be anything. Minimum it can be 3, minimum it can be 3. That means this quantity for no real number x is lying in -1, 1 closed interval. It is for any real number x minimum 3 or beyond 3, but never is it less than 3 for any x. And if this is for no x less than 3, or basically within -1, 1 closed interval, for no x can sine inverse act upon this complete expression. So this particular thing is not defined for any x. It's not defined for any x. So there is no x, that x does not exist for which this expression is equal to 2 pi. Clear? Next we have if -1, 1, if -1 is less than equal to x is less than equal to 0, then tan of this expression is equal to what? Now see very clearly, if you know the very formula, you know that sine inverse of 2x upon 1 plus x square is twice of tan inverse x. But that is only valid when x is lying in -1, 1 closed interval, right? When x is lying in -1, 1 closed interval, only then it is valid. So over here x is lying in -1, 0 closed interval, which is contained in -1, 1 closed interval, right? You know that -1, 0 closed interval is contained in -1, 1 closed interval, right? So you have sine inverse of 2x upon 1 plus x square being very conveniently replaced by twice of tan inverse x. So now you have tan of half of twice of tan inverse x. Then you have plus half of, again, cos inverse of 1 minus x square upon 1 plus x square is equal to minus of tan inverse x, but that is only valid when x is lying in minus infinity to 0 closed interval. So, over here x is lying in minus 1 0, this closed interval, and this is very conveniently contained in minus infinity to 0. So, I can again very easily replace this cos inverse of 1 minus x square upon 1 plus x square by minus twice of tan inverse x. The moment I am able to do this, I basically get tan inverse x minus tan inverse x, which is 0, tan of 0, that is 0. So, my answer actually has come out to be 0. Clear? So, please keep in mind where is x belonging, only according to that I am able to apply the formula and replace these terms by or write them in terms of tan inverse. Now, the next question says that if sine inverse x whole square plus cos inverse x whole square is 5 pi square by 8, then x is equal to what? Let us see. Now, again over here, because sine inverse and cos inverse are being paired up together in the question, I am going to apply a very expression of formula which is going to connect both of them. How does that happen? Sine inverse x whole square. Now, cos inverse x can be written as pi by 2 minus sine inverse x. Why? Because sine inverse x plus cos inverse x is pi by 2. So, cos inverse x is pi by 2 minus sine inverse x. So that everything is just converted in terms of one single trigonometric function, which is sine inverse. So, that is what is given to us as 5 pi square by 8. Let us open this stuff up. You have sine inverse x whole square plus pi square by 4 plus sine inverse x whole square minus twice of pi by 2 into sine inverse x, that makes it pi sine inverse x. This is 5 pi square by 8. So, you basically get sine inverse x whole square plus sine inverse x whole square, which is twice of sine inverse x whole square minus pi sine inverse x, and then you have pi square by 4 minus 5 pi square by 8. You have pi square by 4 minus 5 pi square by 8. So, this gives you minus 3 pi square by 8. So, you get minus 3 pi square by 8 is 0. You can very easily see this is a quadratic equation in sine inverse x. You on solving are very easily going to get sine inverse x equals minus pi by 4. So, very conveniently, because this is lying in the principal domain of sine, which is minus pi by 2 closed interval, x comes out to be equal to sine of minus pi by 4. Sine of minus theta is minus sine theta, so this comes out to be minus sine pi by 4, which is minus 1 by root 2. Therefore, your x is coming out to be minus 1 by root 2. Clear? It is for this x that this expression is equals to 5 pi square by 8. Okay, that is how you need to deal with the questions on inverse trigonometry. Please revise all the concepts very nicely and be thorough with all the questions. That's it from my side. Thank you.